Welcome to your IELTS listening practice from Spinta.org. This is a mini-test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
Good afternoon, and welcome to today's lecture on the ocean acidification process. Today we will explore the critical topic of how carbon dioxide, or CO2, absorption impacts our oceans, and consequently, the marine ecosystem. To begin, when we speak about ocean acidification, we refer to the phenomenon whereby carbon dioxide from the atmosphere is absorbed by seawater. Ocean waters are a natural buffer for CO2, thus leading to an increase in the water's acidity levels. This process is driven primarily by human activities, mainly the burning of fossil fuels and land use changes, which increase atmospheric CO2 concentrations. First, let's discuss how CO2 actually interacts with seawater. When carbon dioxide gas diffuses into the ocean, it reacts with water to form carbonic acid. This reaction is significant because it leads to a series of chemical processes that result in the formation of bicarbonate and hydrogen ions, which in turn cause the pH of ocean water to drop. This drop in pH signifies increased acidity and can have detrimental effects on marine organisms. You might wonder how critical this drop in pH is. Essentially, as the ocean becomes more acidic, it can adversely affect the physiological processes of various marine organisms. One notable example is coral reefs, which rely on calcium carbonate to build their skeletons. Coral reefs are vital for marine biodiversity and provide essential habitats for countless species, thus their degradation poses a severe threat to marine ecosystems. Coral reefs are not the only marine entities impacted by ocean acidification. Shellfish, such as clams, oysters, and some species of plankton, also rely on calcium carbonate. Researchers have found that as CO2 levels rise and water becomes more acidic, these organisms struggle to maintain their calcium carbonate structures. Consequently, their growth and reproduction are negatively influenced, leading to a significant decline in their populations. Additionally, it is vital to note that the effects of ocean acidification are not isolated to just structural impacts on marine organisms. The complex web of marine life interactions can perpetuate a cascading effect throughout entire ecosystems. For instance, reduced populations of shellfish can affect species that rely on them for food, thereby altering predation patterns and further destabilizing marine habitats. Research indicates that the overall biodiversity of marine organisms may be threatened due to these interactions. Some species, particularly those that are less adaptable to changes in their environment, may face extinction if current trends persist. Consequently, this impacts not only marine biodiversity, but the economies that rely on fishing and tourism related to vibrant marine ecosystems. Now let's turn our attention to the carbon cycle. The oceans play a multifaceted role in the carbon cycle as they act as both sources and sinks of carbon. However, the growing amount of CO2 can disrupt this balance. The carbon cycle's equilibrium is delicate, consisting of various natural processes by which carbon is cycled through the atmosphere, land, and oceans. Understanding how human contributions through industrial activity distort this balance is crucial in evaluating the implications of ocean acidification. For example, amongst the myriad of impacts, ocean acidification alters the absorption capacity of oceans, which might contribute to heightened atmospheric CO2 levels. A positive feedback loop is established as increased atmospheric CO2 results in more acidification, which in turn decreases the capacity of oceans to absorb CO2, exacerbating the original problem. Research findings have shown that ocean acidification can also influence marine life behaviors. It has been observed that CO2-rich environments can affect the sensory perceptions of fish, altering their ability to detect predators and mates. This alteration poses severe implications for population dynamics and ecosystems as a whole. In addition to the biological impacts on marine organisms, ocean acidification also concerns the socio-economic implications. Communities that depend on marine resources face significant challenges as their livelihoods might be jeopardized by diminishing fish stocks and declining overall marine health. This needs to be addressed through sustainable practices and policies that can mitigate the impacts of climate change and ocean acidification. The scientific community is actively researching various approaches to mitigate these impacts. Reducing atmospheric CO2 emissions is paramount, and many scientists advocate for immediate action in carbon reduction strategies through policy changes and carbon sequestration techniques. Innovations such as artificial reefs, which can provide habitat for marine organisms while mitigating acidification effects, have also been put forth. Furthermore, establishing marine protected areas can provide resilient ecosystems capable of withstanding some adverse effects of ocean acidity. While there is no silver bullet solution to reverse the increasing threats posed by ocean acidification, integrated approaches combining scientific research and community involvement are essential to developing effective strategies. In conclusion, understanding the ocean acidification process and its extensive consequences on marine ecosystems is crucial for both science and society. The absorption of CO2 by human activity has far-reaching effects on marine life, industries, and even global climate regulation. Future research must focus on creating more resilient marine environments, addressing carbon emissions, and fostering public awareness about the importance of our oceans. As we move forward, it is essential to remember that every action we take can contribute to either the degradation or the recovery of our invaluable marine ecosystems.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.